Aw.
What's wrong with you?
Ran out of chips. Olivia! Chips!
Sure, Misha. Give me one moment.
Can I grab a drink too?
No problem, Max.
Now, this is what I call the future. Robotic servants doing our bidding, also that we can be as lazy as we want to be. You know, there's a whole world out there of machines designed to do work for us.
You're right, and if we can get our hands on it, that could be the key to a life of leisure. It's just a bit of a shame about all the technicians.
I'm Misha Pollard, engineer and gadget guru.
I'm Max McMurdo, designer and tech upcycler.
We don't want to wait another decade for the planet's most amazing prototypes to reach our home.
This is the future.
We want it all now.
So we've teamed up to search the planet for gadgets that will blow our minds.
Do we take it off?
From futuristic robots
That is impressive.
to superhuman enhancements.
That's great.
And use them as inspiration to build some future technology of our own, against the clock and against the odds.
We create our very own Machine Impossible
It'll work out good.
and unleash it on the world.
Let's do this.
Perfect.
This time, we set out to discover how machines could make going to work a thing of the past.
If I was that fast, I'd hurt myself.
On our global road trip, we'll uncover some of the world's hardest working gadgets. He's just showing off now, isn't he? Could this tech teach us a thing or two about teamwork?
He's a bit like being at the ballet.
Make it possible for us to be in two places at once.
That is genius.
Or even take our place in a danger zone.
I am now imagining the future.
We'll also attempt to build a machine to do our bidding.
That
Yeah.
is instant. But will it buy us more me time
Send it for some food.
or have us working overtime?
I need more from you. You're very static.
Let's get this show on the road.
Where first?
Japan.
Of course, a country that's embraced mechanical manpower like no other country on Earth.
And, as it happens, home of the world's biggest robot exhibition, IREX. If we want to learn about the future of workplace tech,
It's quicker than you are.
If I was that fast, I'd hurt myself.
we're going to have to educate ourselves in the present.
This is brilliant. So, imagine you walk around an exhibition like this, and you've got a dead weight. You put it in a box. This follows you around all day.
Let's test it. Holy, it totally follows you.
That's impressive.
If we're going to find inspiration for our very own work-related Machine Impossible, it might help us to figure out what work it should actually do. And one thing that becomes apparent at IREX is that the job each robot is built for can be quite specific.
Right, take a seat. You know when you're really hungry, you want to eat, but you can't be bothered to lift your arm up.
This is like the movie Seven.
IREX was quite incredible for me. I've never experienced robots firsthand like that. All you have to do is open your mouth and consume the food.
I don't know how many people have put their mouth on the spoon. And I found it really impressive how all the different companies had intricate robotics that wasn't flamboyant, come and see this. It was more, we've created something and it might be exactly what you need.
Like Aero DRC, a four-legged humanoid, moonlighting as the world's most high-tech bartender.
All right, my good man, I would like a green tea, please. This thing will get it right every time.
Here's the deal. If you get the sponge, you have to eat the sponge.
Deal. No, 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 no. Oh, my God. Oh! I'm never going to drink this green tea.
When it comes to robots designed to work in service jobs, like on shop floors and at events, designers strive for the human touch,
Are you looking at me? You must be looking. Nope, he's not looking at me.
which some machines at IREX pull off with surprising authority.
She was like sitting 20 feet away in a pub. I'd give her a little nod. It would take me a minute to realize she wasn't human.
Primarily a show host and guide, the Actroid DER2 might one day find work as a fashion model. Tiny air actuators under her silicon skin gives her 47 different articulation points across her body.
I'd like to see her stripped back. Not stripped bare, stripped back. So, robot-y things.
The Actroid humanoid robot was strange. I don't know where it's gonna be in a work society. I can't imagine that working at the front desk of some place. It's just too strange. You truly want a human touch.
I disagree, Misha. I reckon given the right job, a humanoid robot could be a game changer. We need to keep this in mind for our own machine.
That's creepy.
Of course, there's a more serious side to IREX. Japan is in the midst of a robot revolution, a push to encourage the use of intelligent machines, especially in construction and manufacturing.
They need to do like a viral video of it like juggling 3 cars.
By 2020, Japan hopes to be spending a whopping 2.4 trillion yen on its robotic workforce. So the race is on for more power, more speed, and more accuracy.
Nowhere is this more pronounced than in Japanese car manufacturing.
7 organized spot welders. This is the kind of thing that makes me really appreciate robotic systems. Everything working in unison, choreographed robotics.
They almost look like birds of prey or something.
It's what robotics should be when it's done right. The speed of it, the power of it, and how fast it goes. And it's kind of scary when you think about what it's capable of. It's impressive, but also eerie in a way.
I could tell you were impressed by that.
Totally. I think it's the route we should be taking with our own project. Now, if we had a machine with real muscle, it could be the end of hard work as we know it.
I assume that's why we're on our way to the wilds of northern Germany. So you can convince me.
I've brought you here today to see the machine that made these tracks. This is a machine that takes the hard out of hard labor. And all we gotta do is follow the sound of falling trees.
That is a machine. That's a monster.
This is the Scorpion King. A 23-ton behemoth built by logging specialists Ponzi. Powered by a 286 horsepower engine, wielding a crane with a staggering reach of 11 meters, and a harvester head that can strip trees bare at a speed of 20 feet per second.
Both of us are eco kind of guys, so the whole idea of felling trees kind of feels weird, even though I know they're doing good things out here.
So, is it any wonder we're so intimidated?
Hey, I am a human being!
But here to reassure us that the Scorpion King is actually a friend of the forest is Ponzi's Yampa.
Hey, I'm Misha.
Yampa. Is it all necessary, or is that just for show?
They are for the limbing.
That just de-limbs it and takes all the branches off?
Yes, and this is very sharp. And feed rollers and the knives will grab the tree. These two, they have a hydraulic motor over here. And for these feed roller, we have 2 hydraulic motor both sides. And these all together will pull the tree through the limbing knives.
Now this isn't just environmental violence. The Scorpion King is here for what's called thinning. In a country where pine trees make up almost a quarter of their forests, it's a means to give the stronger trees increased space and light.
It means that we don't cut all the trees down, but we leave kind of a certain distance always to standing good quality trees. We are always taking only the bad quality trees away.
The Scorpion King is one of those rare machines that combines both brains and brawn. Its large wheelbase is designed to reduce its physical impact on the forest floor,
while an onboard computer system measures the height of every tree it fells and feeds this back to the machine so it can better cut the next. It's actually quite delicate and intuitive and intelligent.
There's work to be done, and if you don't ask,
Can we learn in 5 minutes?
Let's say 10, 15 minutes.
Even for people who've never used anything like this before. I was excited and scared when we were told we could have a go ourselves, especially when he said he could train us in about 10 minutes. I thought, no, that's impossible.
thinning is straightforward. Cut the trees marked with red, don't cut the trees marked with white. But the machine may be a little trickier.
You activate the tilt. Close the harvester head, use the saw button,
Left, 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 thumbstick left, and I'd be like, what? Wait a second, you did that. And he's like, oh, you could do that too.
and now I push here the button, fine.
Maybe not the greatest training ever.
Okay, it's your turn.
Yes.
Could we become 21st century lumberjacks?
And there he goes.
The answer is probably.
This is the first tree I've ever cut in my life.
Once you get a grip of the controls, you find that this is more or less a big remote-controlled arm.
Yeah!
Just one that could kill you in about 6 gruesome ways.
And while the arms at IREX welded steel and fixed rivets, this has got me thinking about all the other jobs we could do by remote control.
Oh, he's being a bit gung-ho about it, old Misha.
I agree, but could we really build something on this scale?
Tap.
Computer game nerd.
It's like a real-world video game.
This time on Machine Impossible, we're in pursuit of a life of leisure and making plans to build a machine of our own to make the future of work history.
But coming up with an idea, well, that's pretty hard work. So, in search of inspiration, we're boldly going where no presenters have gone before.
Tell you what, Misha, this is probably as close as I'll ever get to space.
You just feel like you could just reach out.
Now you've ruined it.
Okay, so we weren't really in space, but rather at DFKI, the German home of robotics, and host to all manner of creeping, crawling robots designed to explore the cosmos.
And Isla, easily the second hottest robot we'd seen so far on our trip.
So this is Isla.
She's hot. She's like a sexy stormtrooper.
This is a mock-up of the ISS space station. Missions to the space station are pretty dangerous. Sending a robot might be much cheaper and less dangerous.
And that's where Isla comes in, because Isla is a next-generation telepresence robot.
Telepresence is remote participation. It's a big deal in the world of work, where high-end teleconferencing and tablets on sticks are making it possible for you to have a presence in the workplace, even when you're somewhere else.
If Isla were on Mars, a human being might take control of her from Earth. But, thanks to telepresence, now you're there, technically. It's like the movie Avatar, but with a 5-foot humanoid instead of a 10-foot alien.
It's very complex. So all of these finger joints, they all come together. She can pick things up, grab things.
The fingers are very similar to the human hand, and all joints are activated so we can control them independently and do a lot of things with them.
How many degrees of freedom does Isla have?
In total, it's about 60 degrees of freedom, so 60 motors, joints that we can control independently from each other.
But the way she's controlled, now that's out of this world.
We feel that teleoperation is a very good and intuitive way to control it, for example, by using an exoskeleton.
Do you have one of those exoskeletons here?
Yeah, we have an exoskeleton.
We should go take a look.
Ah, there she is.
This is the Capio, a wearable supersuit used to control Isla, wherever she happens to be in the galaxy.
It is an upper body exoskeleton with 8 active degrees of freedom at each arm. It has an overall weight of 24 kilograms.
What did I win?
The chance to be weighed down by that.
Sounds good.
Because I quite like the look of Isla. I'm going to go and hang out with her for a while.
Get out of here. Go over there. I'll fit up.
The Capio is special for another reason. Feedback is two-way.
Misha, can you hear me or see me?
But with motion. This is called haptic teleoperation.
While I can use the Capio to control Isla, Max can push back.
Hi, Isla, Pollock.
Those forces are transmitted to multiple contact points on Misha's back and arms. And now I'm controlling him.
The force feedback system on Capia was probably one of the most unique wearable robotic experiences of my life because I'd see you on camera rotate my arm and move my arm, and then all of a sudden, I'd feel everything happen and exactly the way you did it. And then I'd poke him in the eye.
What are you doing? Misha, do not punch me in the face through Isla. I know it's still you. Let's make love, not war. Give me a hug.
This kind of force feedback would allow me to push carts or lift boxes, stroke a cat in my space lair, anything that requires me to feel my way around a task.
No.
When you gave me that hug, it was nice because I saw an emotional Misha and you were being very friendly, but then I also thought, he's going to crush me to death.
Oh,
Is that pushing his arm?
that's doing it.
Feedback! However, Isla wasn't just built for PDAs and selfies. Those hands are capable of multi-finger grasping, making it possible for her to remotely flip switches and turn levers.
Powerful.
What can we do to test that?
We need a space.
Space.
Emergency. Space. Let's go and do it.
Red alert, Max!
I feel so stupid.
What are we gonna do?
There's only one person that can flick the switch. It's Isla.
Save us, Isla! Flick the damn switch! No! The other up! Flick it up! You got it!
Toggle switch.
Yes! Oh, gravity and centrifugal force and stuff has been
Resumed.
redone.
Mission aborted, back to Earth.
Into traffic jams, rush hour, the occasional hangover. Now I can see why telepresence tech could be so appealing to your average Joe.
And that's what our build should be about. Being in two places at the same time. Working from home.
But doesn't that already exist? We've got emails, we've got telephone conferencing, we've got the cloud. I kind of think we've missed the boat.
See, but that doesn't work for creative people, like artists, actors, musicians, because they got to be very physical. They have to collaborate with other people. They have to perform. They have to audition. I think we could create a robot that would not only let us be in two places at the same time, but perform in two places at the same time. What do you think?
I think you've lost it.
Picture it. Something with the lifelike charm and poise of the Actroid, but that could be remote controlled like the Scorpion King. Isla showed it could be done, it just needs to be a bit more, well, actory.
Well, the most we could afford would probably be a mannequin, but all the gears and motors to make it posable won't come cheap.
No, there's a simpler way. Think string puppets.
Clever. So what you're suggesting is an all-singing, all-dancing telepresence mannequin, but less Pacino, more Pinocchio.
I give you the Telethespian.
That's some serious remote robotics. That's a bit tricky. We'd need some help.
More specifically, we need the help of mechatronic engineer Adam Turner and software engineer John Reed. AKA Maverick Building Team Robo Challenge. We're on our way to England. Not raising any suspicion whatsoever with our choice of travelling companion.
They do know we're bringing a decapitated mannequin, right?
They're about to.
But on our way to meet our compadres, multi-talented tech wizards Robo Challenge, who are going to help us build a machine impossible to revolutionize the world of work.
This is Bobby.
Hey, Robbie.
So, thanks for helping us out on this one.
That's all right. You looks like you brought everything you need.
Yeah? Should we get started?
Yeah, let's get to it.
The challenge is on. In 48 hours, the wings of this theatre will be littered with expectant actors, anxiously awaiting an audition with Misha, or rather, our telethespian.
Which meant that back here at the workshop, we'd have to put on the performance of a lifetime.
I hope this works. It looks a little bit shonky, doesn't it? And Adam and I would have to figure out how on earth our creation would actually work.
No, it has to be functional first and foremost, doesn't it?
We'd always imagined our mannequin as a life-size string puppet, but instead of giant fingers moving the limbs up and down, we'd be using levers attached to motors.
3, 2, 1.
If we could attach several motors to each limb, laid out in a very specific geometry, we'd be able to move the limbs anywhere we like, in 3D space.
He's waving.
Meanwhile, I'm taking care of the second most important job.
So I have the pleasure of getting to dismember our friend here.
If Bobby here was to break a leg, I'd have to break his arms.
Perfect. Let's do a little bit more dismemberment, shall we? So the team here, we've 3D printed up some hinges, nice and simple, that will bolt on so that we got some good rotation, up and down, forward and back, as well as elbow rotation. Give a little bit more liveliness.
To get the maximum range of motion, I have to hack him up, literally, in all the places I need him to be able to move.
Hello. Thank you.
Including his shoulders, elbows.
Oh, that would be really painful in real life.
And torso. After all, what's an actor if he can't take a bow?
You look like you're having too much fun. Have you done this before?
What business is that of yours?
None. While I get to work welding the steel frame that will support our actor chum,
John and I have locked ourselves in the stationery cupboard to figure out how on earth we're going to control the telethespian.
We'll send that
To the actuators.
at least 8.
USB into the tablet.
Trial and error.
And our solution is genius.
I think we're just going to use a standard game controller. So we can do all the 3 axes on each arm.
Which is going to be great because it means we have proportional control of the arm movement in 3D space, which is nice. And then the buttons, very easily, head motion, torso motion.
and these controllers are really intuitive, aren't they? Even I can use one of these.
USB straight into a laptop. Bit of software on the laptop. Reads the values from here and sends it over the local network.
Once received by a tablet, software will communicate with a motor controller. That's a little device that will tell each of Max's motors to move to replicate what we just moved on the video game controller. Like I said, genius.
Being an upcycling nut, I'd originally planned to use old drill motors to power our mannequin's limbs.
However, we soon discovered that, due to their sheer power, that could result in unexpected amputation. So we have no choice but to power the telethespian with less powerful but more precise and controllable servo motors. But will they pass the test?
I'm not as strong as I thought I wasn't. You made yourself taller.
When I bought the mannequin, I thought it was my height. I think it's just how the cut went, personally.
Right.
Its neck is huge, though.
Now, the moment of truth.
Whoa. Oh, there you go.
So right now it's at the neutral point. So that's half. I can hold it at half. We're doing pretty good for motion.
It actually looks quite realistic.
Before we pat ourselves on the back, this telethespian only has one arm, and crucially, it has no head, which is gonna make it pretty useless in a love scene. Robo Challenge still have some work to do.
So you think we can get all this done in time?
Yeah, I think we can. All we need to do now is attach some motors to these wires here so it can actually bow down.
And John, you think we can just smooth everything out in the software?
Yeah, once we have a better signal, it'll be good.
It'll work out good.
Done?
All right.
Tea time?
Time for a brew.
Tea.
Well deserved. I'm Max McMurdo. You made yourself taller.
And I'm Misha Pollock.
Of getting to dismember our friend here.
And this time, we're trying to get ourselves out of doing any work in the most high-tech ways possible.
We're in the midst of building an all-singing, all-dancing telepresence robot. So while our co-builders, Adam and John, make the finishing touches to the telethespian, we're taking a well-earned day off. Takes a little bit of practice.
Getting good at this. Woo-hoo! Yeah! Nice. I love these things, man. Even in this wind, this flies so well. You know what? Let's fly it to the car and have Soka put drinks on it and send it back.
No, that isn't going to work, is it?
Let's find out.
We already have with us the Ghost Drone, a smartphone-controlled quadcopter. To put this drone to work, all that we need is to attach a makeshift carriage to its landing gear.
What we got? We got zip ties, we got some wire. Why don't
good
I
point.
use the net that the shoes are in?
Better idea.
We got this.
Once the net is attached, we'll fly our drone in the direction of our show's producer, Silka. She'll load the drinks, and Misha will fly it back. Simple. All the ideas you've had, this is definitely one of the most ridiculous.
I think this is brilliant.
If we ever get deserted on an isolated beach together, we'd be great. Tom Hanks didn't do this.
Wilson would be a drone.
All that's left to do is to send her a message.
We can write her a message in a bottle.
Let's just send her a phone.
You send your phone then, I'm not having my phone flying up there.
All right, I'll send my phone.
And it's chocks away.
Put your glasses on.
That looks ridiculous.
That counts for me. That counts. She got us 2 waters.
No.
OK, let's hold it there 1 minute. This hack didn't work quite as well as we'd planned.
See, the ghost drone couldn't actually pick up Silka's waters. So she had to load it with empty bottles instead.
Gadgets 1, Max and Misha, 0. Now, our drone did lift a phone. And spend just a few minutes searching online, and you'll see drones delivering everything from courier packages, the mail, medical supplies.
We're always hacking drones in our projects, so it figures that a crash course in what they're truly capable of wouldn't go amiss. So we've skipped across state to the General Robotics Automation Sensing and Perception Lab, or GRASP to you and me, in Pennsylvania. Specialists in aerial robotics. To meet Mickey Witzer, a scientist and drone wizard, who has promised to show us how they could one day be teaching us a thing or two about teamwork.
Mickey.
Hey.
Nice to meet you. I'm Max.
Very nice.
Misha.
GRASP's research includes the development of large drones, designed to carry heavy objects using grippers and construction tools. But Mickey's drones, also known as quadrotors, are tiny, weighing around 70 grams and only 21 centimetres in diameter. They can barely lift a finger, quite literally.
But if you're planning on sending drones to places humans wouldn't dare to go, like chemical and radiation danger zones, you want to go light, small, and disposable. And these guys have strength in numbers.
Okay, so now we're going to send the robots a mission to cover the center of the room.
Mickey's quadrotors are tracked by their very own air traffic control, a computer system that uses multiple cameras to track their exact positions and send them instructions on where to fly next and how not to collide with each other.
But like all workers, drones occasionally have off days, and Mickey's are no exception.
So right now they're in formation over that center part.
And if we remove one of those drones, the other 3 will go and get coffee.
You can hit the kill switch. Yeah.
If it does come at you, just Kong that thing.
Yeah, see,
Drone fighting.
Thanks.
You look like a magician.
OK, break time over. Back to work.
So what would happen if we removed a robot? Would it recenter itself?
He'll come out of the formation and you'll watch the whole formation reform. And see, now they form a straight line. There you go.
And he covers it.
Cool. All right, let's reintroduce his buddy.
All right. Perfect.
It's like a fledgling bird going back to its mother.
They actually showed some form of intelligence, like they were mates in the field.
So what is this proving? Where's the real-world application for this?
So it shows that if robots are out in the field doing a mission, say keeping surveillance over a territory, even if one goes down, they can still complete the mission as a team of fewer robots.
Not only would these be phenomenal for search and rescue and surveillance, but even for jobs such as bridge checking, where right now people take a lot of time and do dangerous things to go underneath and check it out.
Less menace to society, more contribution to society. Our kind of drones.
He's a bit like being at the ballet.
We've taken on a challenge to build a work machine that could allow Misha to act, fight, bow, and even perform a love scene on stage from a remote location. It's as tough as writing Shakespeare.
But before returning to England, we're making one last trip, this time to South Korea, home of kimchi, K-pop, and KAIST, or the Korea Advanced Institute of Science and Technology.
Misha's heard they have a robot that could be the future of our telethespian project. In fact, one of the most sophisticated robots on Earth.
What are we doing? This is a building site. You said something about robots.
We're supposed to meet Professor Juno. He's got a big robot to show us. Should be impressive.
Hang on a minute. There's something ridiculous going on behind you. What on earth is going on?
This is it. This is DRC Hubo.
DRC Hubo is at the cutting edge of robotic search and rescue, part of a growing number of humanoid robots designed to come to our aid by performing the kind of tasks we take for granted. Bipedal walking, stair climbing, various manual tasks, and of course, driving.
Hello, it's
Hi.
even colder today. Okay.
Nice to meet you. I'm Max.
Yeah, I'm Juno.
Behind every prize-winning robot is a maverick engineer, and DRC Hubo's co-creator is Professor Juno Oh, a globally recognised expert in humanoid robotics.
I'm already so impressed just the way he got out of the vehicle.
For the robot, dynamic movement is very, very hard because nothing is predictable. Very flexible control is needed to achieve that motion.
Unlike our telethespian, which is strictly remote control, Hubo can think for himself. He's linked to human operators, but he can perceive what's around him with his simple vision system, made up of a 3D scanning tool, LiDAR, and a camera mounted on a gimbal. The operator can see from Hubo's point of view and indicates to him where to go and what task is next. But how he performs each task is entirely up to him.
And if you think our telethespian is nimble, Hubo has a rotating torso that allows him to turn 180 degrees, and a customised air cooling system that keeps his 33 motors on the go. He even has his own special move.
He's just showing off now, isn't he? He's transforming into a vehicle.
Yes, that is genius. This is a transformer.
We call multimodal mobility. It's two ways, roll-based or bipedal walking.
So what's the advantage of him rolling as opposed to walking?
It's much more safer and stable for flat terrain. If the terrain is not even, then he may utilize his leg.
This is the first true transformer I've ever seen. That just went from a robot to a vehicle.
Right, enough of the theatrics. Now to convince us you're the right robot for the job. This course is a robot's worst nightmare. Door opening, valve turning, stair climbing.
If Hubo can complete all these tasks, we might be convinced to take him on as our next apprentice. Once the task begins, the operator hands over and Hubo kicks into artificial intelligence mode.
Seeing it sense it, find the handle, open the handle, and test the door until it was open and passed through, really quite impressive to see.
It's fine, Hubo. I'll shut it. The second challenge, I didn't think it was going to do, actually. Turning a wheel is actually quite a complex thing. Again, we take for granted our wrists and the motion we've actually got.
On the valve challenge, you begin to get an understanding of how Hubo's artificial intelligence comes into play.
I'm not sure that what kind of strategy he will take. Depends on size of rib. This big one he handle this way, a small one handle this way.
I love the fact that you invented him, but you can't predict what he's going to do.
That is brilliant.
And by task 3, Hubo's usefulness is becoming abundantly clear.
I can't quite believe what we're seeing.
I am now imagining the future where robots are cleaning windows, walking around, doing tasks.
Where's he going now?
Go over that terrain.
He's going to walk over those blocks.
Yeah.
Really?
Yeah.
Working for us would mean the ability to traverse uneven terrain. You wouldn't believe some of the potholes outside our workshop. His wheels won't help him now. This is going to be nerve-wracking.
He has to measure where to step on, the inclination and position, height, everything by himself.
No.
How many operations per second is he thinking about when he's doing
It's
this?
250 times.
He's more clever than you.
I had seen so many robots over the last few years attempt that, and they had been supported. So to see it do it without any support was just such an incredible thing to watch.
But then,
he had it the whole way. I still love you, Hubo. I'll be here in 5 years.
When Hubo fell over at the end of those concrete blocks, I was kind of really upset, but at the same time quite pleased, because that proved to us that this wasn't a pre-programmed kind of exhibit. What he was doing was actually as incredible as it looked. So next, he's going up these steps.
Yeah. Not most of cases.
That's a big lift.
What?
Words. Where is he?
Come on, man.
One more.
You can do it!
One more, Hubo. Yes! You're a hero, Hubo. Can I hug him?
Just don't push him down the stairs.
Just a little hug.
This is incredible. Professor, your team has done just an amazing job.
It's ridiculous. You must be very proud.
Thank you very much.
this time on Machine Impossible, we set out to explore the world of work technology and asked the question, can machines really cut us some slack and give us more me time?
Our journey inspired us to build our very own hacky version of a telepresence bot, the Telethespian, a robot that could allow Misha to perform on a stage with real actors while somewhere else entirely.
That actually looks quite realistic.
Speed is good, though.
And it's almost time for his stage debut.
What do you think?
Oh, it smells so good. It's good to be home.
I do forget you've acted on the stage quite a lot, haven't you?
I can't believe you haven't. I always assumed all British people did it. This place is great, though.
Let me tell you my plan. Now, I'm going to be casting, so I'll be centre stage there in the front row. Directly in front of me, the mannequin. Everyone who's coming on to audition, through that door there.
And I'll make sure I'm in a different room so that we prove what we're going for, that this can work remotely. I think this is going to be good. Let's go get the gear.
It's showtime. We've invited 6 budding young actors to join Misha in our own unique take on William Shakespeare's Romeo and Juliet.
Unbeknownst to them, I will not be performing alongside them. Rather, they will be performing alongside the Telethespian, our homemade gadget built to allow an actor to perform on stage while located somewhere else entirely.
With our frame reassembled,
A very good coffee stand. We have designed my favourite coffee stand.
our body parts rewired, the tablet that would represent Misha's head finally in place, and of course, modesty covered up, it's time to send Misha and his game controller to the stalls for the dress rehearsal.
All right, now left arm,
Perfect. Outstretched.
and now the bow. Good?
It's a bow. Very graceful.
All right, tell me if this is confusing for you.
I think you just confused yourself as well.
Let's do this.
Perfect.
Now, not so fast. To prove our Telethespian can operate not just across the stalls, but across the world,
Can you see me?
we have to conduct our experiment in another part of the theater altogether and rely on a series of Wi-Fi networks to project my hand, body, and head movements as well as my face onto the mannequin.
I need to see me from the stage.
Misha wants to see himself again. It's not a massive surprise.
Now that I can see the mannequin. I once caught a fish this big.
But don't forget our robot relies on Wi-Fi.
I didn't.
And as most of us know, Wi-Fi isn't always the most reliable.
Okay, left arm.
Are you instructing me? Yeah.
There's a good delay there. And this is about the delay we have, so now I'm gonna let go of the arm. 1, 2, 3.
4, 5, 6.
Oh, mate.
So we got about a 5-second ping.
One reboot later, and the delay has sorted itself out.
Right arm.
That is instant, yeah.
Nice.
But it's a stark reminder that our lead actor could throw a high-tech tantrum at any moment.
That was spontaneous.
That's great. Oh,
Goodbye. Thanks for calling.
Did it just sleep or die? They're all wondering what's happening.
Where could he have gone? In, down, at the iPad. Just press answer. That's all we've got to do, one button.
So we have learned here, John, that though this would work internationally...
Good use of technology, Misha Pollock.
If the tablet dies, if the laptop loses power, any of these things occur, my audition's not gonna go too well.
Where are you?
We're back.
All right, El Director, bring in the auditioners.
Great, see you soon.
This is the most relaxed audition of my life.
And your name?
Charlotte.
David.
Eva.
Would you like to stand on the cross just in front of you, Eva? And when the curtain rises, if you would face your co-star, please don't be too alarmed. Curtain, please. Cue the sword. When you're ready, in your own time.
Shall I hear more? Or shall I speak at this?
Thank you. First impression was, that's actually quite impressive.
Come, sir, your passado!
With love's light wings, did I overperch these walls?
Nothing but one of your 9 lives.
And also, great confusion.
In my true love's hand. Sorry.
Misha, I think you're twitching.
How am I not going to be put off by this? Because it just looks hilarious.
With a kiss, I die.
I will kiss thy lips. Haply some poison yet doth...
Hang on. Stop. This poor young lady was trying to kiss you while you inserted a crisp into your mouth. Are you foolish?
I will kiss thy lips. I shall kiss thy lips.
Come, sir, your passado.
Wasn't expecting to see a tablet attached to a mannequin's face.
Here's to my love! Oh, true apothecary!
Yeah, I would definitely give it a try, just because it looks so interesting to just perform in that way.
Let me talk.
Thank you.
Behave yourself. You can't do that.
What did I do?
Kiss the girl twice.
You don't know what the hell you're talking about. You don't understand the energy we put into this.
You don't understand any of it.
Really? After all this?
I'm out.
That's the feedback.
This journey has been undeniably hard work.
Admittedly, getting up close and personal with gargantuan logging machines, overbearing cyborgs, diligent drones, and, of course, a sexy robotic secretary might not seem like your average 9 to 5.
But with the unveiling of the Telethespian, we'd had our own crack at shaping the future of machines in the workplace.
And with our legs well and truly broken, it's time to face our critics.
Here he is, the man of the moment, Misha Pollock.
Hey, everybody.
I felt today was a little surreal, and it has some room to grow. It was a good first attempt.
I suspect if they'd walked on and just read lines to me, and I just sat there static, they'd have been quite flat, quite subdued.
They had something to interact with. They had something 3D, something with movement, something that would look them in the eye.
I think today we've proven the concepts. Telepresence in this environment is potentially viable in the future, don't you?
If you can act with a telepresence robot, if you could create a character and have that emotion, then the simplicity of day-to-day conversation, maybe talking with a doctor, talking with a lawyer, talking with a business associate who's in another country, I think this could be something. Thank you guys and girls so much.